Lab 4, and this is the state machine design, and this is actually the part 1 of the Lab 4. So this is a circuit setup, and we've used four circuit ICs with this circuit. So basically this is our state diagram, and this is our K maps we use to interpret our schematic diagram. So basically we've used four ICs, so that is 86 IC, 00 IC, 08 IC, and 107 IC. So there are two inputs. That's basically the EN and CW, which is EN is the enable stripping one, and the CW that controls the direction, and both are connected to the switch here. So this basically you can see, so now the EN is enabled, so it enables the movement of the light, and this is basically the CW that controls the direction. So when you want this pattern to go in the clockwise, so you press 1, and when you want it to go in anti-clockwise, you press it 0. And part 2. So this is the construction of the linear feedback shift register. This is constructed from a shift register that is the 164 IC, and an exclusive OR IC that is the 86. So, and this is arranged in such a way that the shift register goes through the maximum sequence of states. And so as of now we've just given the frequency to 1 Hertz, so you can see the states clearly, and you can see the switch is in 0, so that is it is in ground. So basically this is our diagram, this is a state diagram, and this is the predicted the diagram, the graph we've drawn. And so it actually goes from 110 and 111, 011, 001, 100, 010, 101, 110, and back to 111. This is how the state goes. And now when you want to observe this X0's output in oscilloscope, we need to change the frequency to 5 kilohertz, 500 kilohertz. This frequency is given so that you can see the output clearly. Only with this speed the output will be given in the oscilloscope. So this is the output we got when we connected our circuit to the oscilloscope, and this is exactly the predicted results. And the part B of that is making a 7-bit LFSR with a sequence of length 127. So this is the circuit constructed using this particular equation. So that is x7 equals to x3 exclusive to xo. And we just did the same thing as the previous one, that is this one, but we in the second part we've just changed this XOR gate to the different one. So that is this connection, which is x3, which was initially for q1, is shifted to q3, and x0, which is initially was in q2, which is now shifted to q6. So we are going to see the change, the state change, and this follows a pattern of 100 to 011 and 101, 110, 111, 011, and back to 100. So when you want to observe this particular output in the oscilloscope, you need to change the frequency to 500 kilohertz. And as you can see, this is the output you get it in the oscilloscope. And when you see, compared to the first one, this is random now. So when I stopped at this point, this gives this kind of graph, and when I run it again, and I stop, and now you can see the variation. Now this is the second type of graph you get. So according to the output we get, we can say that this is a random output. The part 3, that's the last part of the lab, and this is basically the mill state machine to detect the sequence of 011, and this is our state diagram. and this is our K map. And this build circuit is built using the four ICs, and that's basically the 164 and 8674 and 00. So there's this exclusive OR IC and NAND gate IC and D flip flop IC. So this is our schematic diagram, and this is where our W is, and this is where the F is. And so basically one probe of the oscilloscope is connected to the F, and another probe is connected to the W. So this is connected to the oscilloscope to check. So whenever there's the pattern of 0 1 1, and here there's an output of 1. So as you can see, it says 0 1 1, and you can get a pattern of 1. And then here 0 1 1, you get a pattern of 1. Same here, 0 1 1, you get a pattern of 1. So this is basically a part 3 of this lab.